Long ago, surviving was about storing energy when I could, and making it last when I couldn't. Today, the very traits that once kept humans alive can work against us. That idea sits at the heart of the thrifty gene hypothesis. The basic question is simple: why are obesity and type 2 diabetes so common in modern societies? One proposed answer is that some of us inherit genes that are extremely good at saving energy. Genes that helped our ancestors get through regular cycles of feast and famine. What does thrifty mean here? It means bodies that store calories efficiently, as fat slow down energy use when food is scarce, and quickly refill energy reserves when food returns. In 1962, geneticist James Neal suggested natural selection favored these thrifty traits in environments where food supply was unpredictable. In that world, thriftiness was a survival tool. If I could store a little extra after a successful hunt or harvest, I had a better chance during the next lean season. If my metabolism shifted down to conserve energy, in a famine I could endure longer. Over many generations, groups exposed to frequent shortages may have accumulated more of these energy-saving variants. So why does thriftiness become a problem now? Modern environments flip the script. Many of us live with year-round access to energy-dense food, less physical activity built into our days, and high stress with poor sleep. The same genetic settings that once protected against scarcity can backfire in abundance, making weight gain easier, insulin resistance more likely, and type 2 diabetes more common. Still, genetics is only part of the picture. Obesity and diabetes are polygenic, shaped by many genes, each with small effects. And genes interact with environment, diet, movement, sleep, stress, medications, social conditions like income, work schedules, neighborhood design. Two people with similar genetics can have very different outcomes depending on these factors. It's also important to know that science is still debating the thrifty idea. Alternatives include the thrifty phenotype hypothesis, suggesting that early life undernutrition programs the body for thriftiness later, and the thrifty gene hypothesis, which argues that random genetic drift, not selection for thrift, explains weight variability once predators were less of a threat. The truth may combine pieces of all these views. Here's the reassuring part. Genetics is not destiny. Risk is not fate. Habits and environments can nudge biology in healthier directions. Regular movement makes muscles hungrier for glucose. Fiber-rich foods slow absorption and enhance fullness. Consistent sleep supports hormones that regulate appetite. Stress management reduces signals that push us to store energy. Medications and medical care, when needed, help the body use insulin more effectively. Small, steady changes matter most. A daily walk, a glass of water before meals, adding vegetables or beans to the plate, going to bed half an hour earlier. Building a routine you can keep is more powerful than chasing perfection. If I think of thriftiness as a setting, I can design my surroundings to work with me, not against me. Keep healthier options visible, plan meals, arrange my day to include movement and seek support from friends, family, or care teams. Community choices matter too. Safe parks, time for rest, access to affordable, nutritious food. The big idea is simple and calm. Human biology evolved for survival in scarcity. Today, understanding the past helps me make kinder, smarter choices in abundance. Knowledge turns risk into something I can navigate. Thanks for watching. Brought to you by DiabePhysics, where knowledge meets control.